Hello YouTube. My plan is to make my ConStands MD4Z tire changing assembly work more like a Rabaconda, which is all the rage right now. And I wish I hadn't already bought this one. I may have plunked down 3 to 4 times the money to buy a Rabaconda. But I'm not going to have both. Thank you very much. Anyway, the ratchet assembly I'm making is using these pieces, and we'll see how well it works. This tube is a 1.5 inch square. These dimensions on these tubes are on the outside. Same thing with the angle. They're 1.5 inch square with 1/16 inch wall or 16 gauge. The lever arm slides inside this very snugly. We got 2 pieces of 1.5 inch 3 by 3/16 thick angle. A little longer than this would be more ideal, I think, but these are about 5 inches. Got a piece of 1/8 inch plate, and all of this is steel, by the way. It's a piece of 1/8 inch plate I'm going to use for the top piece on top of the ratchet. And these washers, this one, the small one, is a machine bushing 1 inch ID. The larger one is a one I will drill to 1 inch, and I'll use it as reinforcement underneath this. I have a 2-screw stop collar 1 inch ID to go down over this to hold it all together. This tube is 0.75 with 3/4 inch ID and 1 inch OD, and the tube or the spindle that sticks up from the tire changing machine will slide through that. When it's through, it'll only be a little higher than the surface, probably using less than 1 inch of material, actually. This is 2 inch by 3/16 inch wall steel tubing, and it slides over the duck head assembly, and then it butts into the weld on the bottom side. So I will be compensating for that instead of grinding. My ideal is to not make any changes to the original machine. But with any luck, the only thing I'll have to do, if it comes to it, is put a nut here, one of these, so I can move the lock bolt to the side. You don't want it on the bottom because it might conflict with the anti-rotation pin. You don't want it on the right because it might conflict with the lever bar, and you don't want it on well, I guess that's it. You only want it on the left if it's conflicting on top still. This plate I may use as reinforcement on top of this to stiffen the assembly. And this piece, 3/16 inch, I'll probably cut and use it as the hook that goes over here to hold the pry bar in place. I was trying to figure out a way to make the ratchet assembly, and after searching online over and over, I discovered the idea of a come-along. It's like, duh, okay, well, I had a come-along that I've used maybe once in the last 25 or 30 years, so I sacrificed it, took it apart, and unfortunately, though laminated construction is supposed to be strong, this is held together, wedged together with this central core and welded on the outside only. So once that core is removed, all of these are going to separate. So I'm going to have to weld them together with plug welds or something, and they will be attached to the top of this tube. And you can see that it'll still clear for the adjustment in length. You can probably still do as small as 14-inch wheels with it. And the pawl will be, one of these will be used as the pawl, and that'll be mounted on the underside of this. And one of these springs will be used to keep it in place, engaged with the ratchet. And that bolt is just to keep spatter off the threads if I have to weld the nut to the side. So it's a pretty simple concept, and I'll let you guys see the parts as I make them and put it all together, but I won't be showing any welding because I'm not a very good welder. Took a class about 40 years ago, and I've probably done 10 to 15 feet of bead since then. And you pretty much need an angle grinder with a cutoff blade or a chop saw to cut the pieces, and a drill press or a hand drill if you're confident, and a welder in my case, but it could possibly be done with drilled holes and screws through tapped holes to assemble it. But I'll keep you up to date. As I do the job, I'll make more additions to the video and let you see how it comes out. Okay? Since it's basically easier just to take apart both laminated stacks of the ratchets, that's what I did. And I will plug weld them using these inner areas here. And then drill them out using this as a guide for the diameter I need. And then weld them onto this rod and this sleeve. Well, I did tell you that my welding sucks. This is my basic drawing. This is where I am so far. Lots of grindage going on there. Let me show you how it fits the machine. Here it is in place. So we'll see how it goes. Yes, this is just how cheap I am. I have 2 pieces of 1/8 inch plate, and I'm plug welding it together to make a 1/4 inch piece for rigidity. I have a 5/16 piece, but that's a little too much for my welder to handle. So I'm not going to be going anywhere to try and find some scraps again. I'm going to make do with what I can or have until I can't. So wish me luck. Another stage completed. More incidents of the crappy welding, but it's not the smoothest, but it rotates. Hopefully I can have it finished tomorrow when I have a few more hours. Here's most of the pivot and swivel assembly ready to be welded together. I'm going to plug weld here, take it apart, run a weld at the bottom on this side, that's the side that the force is applied to, and go ahead and do the other plug weld over here. Then I'll put it back together after cleaning up the weld inside, clamp it, and do the 2 plug welds on the other side. Then from there is the ratchet pawl on the bottom, and the spring to operate it will attach here on one end. And then let's paint it and assemble it. Here's what I'm calling the swing assembly or pivot assembly or ratchet assembly. Welded up and disassembled, ready to be have the ratchet pawl mounted to the underside and the spring installed, and test it, and then patch stupid holes like my bad plug welds, and things like that with a little painter's caulk and spray paint it silver to kind of match the machine and call it done. Hopefully it'll test out okay. Here's a little test of the ratchet mechanism. Obviously it's not ready for use, but seems to work. Okay, well here are all the pieces that I made to do this little project. Got the top plate, 2 pieces of angle attached to it, a spring attachment point this way. Would have been a lot better to do this with 1/4-inch plate, but I didn't have any and I didn't want to go beg for some more at another shop. So 2 pieces of 1/8 inch thick plug welded together, poorly I might add, will do the trick. Here's the base piece that slides over the duck head assembly. Some of my early crap welds, and by the end my welds were looking pretty good. And also it would be a good idea if you can get one of these or make one of these out of 1/4-inch or 5/16 steel instead of laminated steel like I had to do and plug weld it all together and get it all crappy looking. When I installed this to this and welded it in place, I tack welded it and I slipped it onto the machine and used the pivot shaft for alignment, and I had it on the duck head assembly. And it turned out that the top of it, the shaft that goes through, or the tube that goes through the duck head, similar to this, had the top surface recessed just a little bit, and this settled into it. And when I tried to remove it, it wouldn't come off. So I had to grind off the tack welds again and wrap some fine wire around the shaft and put the end of it down through the hole, and then slide the this over it to cause the bottom of this to lift up just a little bit so it wouldn't drop down into that recess again. So this is obviously for hooking the pry bar, and this is the shaft that the lever from the machine goes into, if I said that right. This is the tube that the lever from the machine goes into. I rounded it this way so it can pivot up inside of this assembly right here. I'm attaching that with a 1/2-inch bolt with a 2-inch unthreaded shank. I cut this spacer from a 1/2-inch steel tube that I happen to have laying around to fit inside of here. And this was made from the one of the pawls from the old come along. Cut a piece of steel, drilled it, welded it on there. I used the one that had the spring attachment to it, so it'd have a bit of a lap joint available in addition to the butt joint. Looks like something from Jurassic Park or something, doesn't it? Anyway, to weld this bolt into it, I had the bolt head on top, and I mounted it where it actually attaches and tightened the bolt, and then or tighten the nut, and then I cut half of the head off, welded it where they come together, cut the other half of the head off, and welded it again so it would be attached as one piece. So those are the basics. This spring was part of another spring that was about the right strength, but I didn't have one the right length. So I cut it off, and it works really well. So I'll show it to you after I assemble it, and we'll see what you think. And here it is assembled. There'll be a lock nut here. I will probably put Loctite on this nut or stake it with a punch. It keeps trying to come loose. But as you can see, now, question is, will it stand up to the rigors of removing a tire? And this is how this is intended to be used. Slide the adapter over the duck head assembly. This pipe is to represent a rim, a wheel. Okay. It pushes firmly. We'll see how it works. I may dismount a tire to try it out, but maybe not. My brother was in construction for a few decades. He had a saying, a little caulk and a little paint will make it look like what it ain't. Looks a lot better now, huh? That's the end product. I'll see. I might do a video of using this and see if it actually doesn't break. Well, that's it. Hope you made it all the way to the end.